Okay, motorcycle and rider of combined mass 1,000 kilograms travel along a horizontal road with the engine producing a forward thrust of 1,500 newtons against a variable force of resistance of 5v squared. Given that the motorcycle starts from rest, find how fast it is going when it's travelled 200 meters. Okay, so force diagram as per the norm. Okay. So with the motorcycle rider combined mass of 1,000 kilogram, okay, so it's got a forward thrust of 1,500 newtons, okay, so it's accelerating, that's the direction of motion, and it's got a resistance, a variable resistance, which depends on the speed. Okay, so 5v squared. So what we're going to do now, of course, as per the norm with these, we're going to apply Newton's second law of motion in the direction of increasing motion. So we're well aware, of course, that Newton's second law says the resultant force is equal to the mass times the acceleration. Now, resultant force, obviously you've got the driving force here, the forward thrust, which is 1,500, less than the resistance, which is 5v squared, okay, and that will equal to then the mass, which is 1,000 kilograms, so 1,000 times the acceleration then, okay, A. Now, one thing we can do here is, notice there's a factor of 5 here. Okay, so we could divide through by 5, and that's kind of important because we want to get like 1 in front of that v squared. So if I divide by 5, 1,500 divided by 5 is 300. 5v squared divided by 5 is just v squared, so minus v squared there, and then this will be 200a. Okay, so then we're going to replace a then with a differential. Okay, now as in cases before, we said a was dv by dt, okay, but in this case I'm going to say, since a is equal to vdvdx, I'm going to use that usage this time. And the reason why is, when you look here, it says that how fast is it going when it's travelled 200 meters. So in this case, when it says how fast, we're talking about the speed, yeah, v, and then when it's travelled 200 meters, we're referring to the distance, x. So it's sort of linking v and x here, yeah? So that's why I want a in terms of v and x, not v and t. Okay, so that's what you've got to look out for in this case. So because we want v in relation to the displacement x, that's the expression for a I'm going to use. Okay, so I get that. And then going to separate the variables as we normally do. So we're going to get the v's on one side, the x's on the other side. So what I'll do, I'll take this dx up to here. So integral of, well, if I take the dx up here, I'm just going to have that. Keep the 200v where it is. Okay. And because I've taken that dx up there, you've got to take this over here and divide. Okay. Now one thing we could do there is take out the 200, and then we've got to decide how we're going to integrate this. Okay, and it goes back to the fact that if you differentiate the bottom, you get the top. Okay, so you end up having ln of the bottom, yeah. And when you look at this here, when you differentiate the bottom, you get minus 2v, don't you? When you differentiate the bottom, you get minus 2v. On the top, you want to get minus 2v. Now, that isn't the case. It's not minus 2v. So what we can do, we can play around with it. And if you multiply the top by minus 2, okay, well, when you differentiate this now, you get the top. But because I multiplied the top by minus 2, I've got to sort of pay back then and divide by minus 2. So I'll do that outside the integral. So we get that there, okay? So when you integrate then, obviously, we've got 1 here with respect to x, that becomes x. This is minus 100, 200 divided by minus 2. And then you've got ln then of this here, 300 minus v squared. Okay, and don't forget then the constant of integration. Okay, so we're now going to work out what that constant of integration is. Okay, and it says here, given that the motorcycle starts from rest. Okay, well, we know rest v is 0, yeah? And we want to think of the distance x then being 0 at the start as well, okay? Because we're measuring from the start. So we can say, look, when x is 0, v is 0. So plug it into the expression that we just got for x. So 0 equals minus 100 ln 300 minus 0 squared plus c. Okay, this implies then that c is equal to 100 ln 300. Okay, so therefore, if I plug it back in here, I'll have x equal to minus 100 ln 300 minus v squared plus 100 ln 300. Swap them around. Okay, so 100, and in fact you can factorize 100, can't you? So we could have ln 300 minus ln 300 minus v squared. Okay, and then you'll notice, okay, so 100 is a common factor. I factorized it, this, take away this, because we've got logarithms taken away. We can then write this as a single logarithm of ln 300 over 300 minus v squared. Okay, that divided by that is a single logarithm. Okay,